Hey, Dr. Greco and any evaluators watching this video. My name is Wade Mileto, and this is my extra credit video on the public lecture I enjoyed the most this semester. The lecture I enjoyed the most was the lecture about cosmic rays and how they travel in space. I honestly had absolutely no idea what to expect when the title of the presentation came up, and all I hear is Dr. Greco talking about some aliens or other during class. Uh, just the sheer title of it intrigued me enough to want to go observe the lecture and find out what in the heck this man was talking about. Turned out he was talking about something I had never heard of, cosmic rays. And being an aerospace engineer, anything from space must be somewhat interesting. The major points of the presentation included what cosmic rays do and the different ways we can detect them. Small background, I think, is required before I can get into what cosmic rays do. Cosmic rays were discovered by V.F. Hess, and he discovered this because it was found that radiation increases as one moves up in the atmosphere. He received the Nobel Prize for this discovery in 1936. I was trying to look up other information on Hess, but even the Wikipedia article doesn't go past winning the Nobel Prize. Nothing else seems to be known about his life. Cosmic rays, when entering the atmosphere, collide with other particles. This accelerates them to approximately light speed. One would think this would mean all particles move fast enough to make the ground. I mean, light speed's pretty fast. You'd think something moving light speed would hit the ground, but only the truly high energy particles can make it that far. These have an energy equal to or greater than 1 times 10 to the 15th electron volts. What the cosmic rays do for science is they cause radiocarbon dating to exist. They cause electronics to mess up, have problems, create errors, and they have a possibility of being involved with lightning. We're not entirely sure about the lightning being confirmed. The lecturer only touched lightly on each of these, but I looked into them a little bit more. According to several sources, automotive electronics are particularly affected by the cosmic rays. The electronic device gets bombarded by the particles coming from space and develops small errors that are hard to detect until they grow and develop into a larger error, which corrupts the electronic device. As far as the lightning possibility, the sheer speed of the cosmic rays would cause electrons to split and cause a chain reaction to form the lightning. Once again, we don't know for sure if this is true, but it's definitely a possibility. Now on to how we detect these cosmic rays. Two of the places where scientists detect the speeding rays are in Argentina and at the South Pole. The Argentinian location is called the Pierre Auger Observatory. They use specialized telescopes to view the particles and track them as they approach the Earth. The base at the South Pole is the IceCube neutrino detector. This one is buried well below the ice, where it collects info about the incoming particles. I looked into both of these farther, though unfortunately the Argentinian's location's website just talked about what cosmic rays are, and I already mentioned that. The IceCube detector got into a lot more detail about advanced electronics and how the electronics go about transferring data between each other to measure results. A lot of this was extremely technical, and I really didn't want to go into detail on it in this video. Overall, I feel like I learned a good deal from this lecture. The topic was certainly interesting and has opened a door for me to look farther into the subject. Hope you enjoyed the video. Have a good day.